In this video, we're going to look at an integral where it's maybe a little less obvious what a good substitution versus a less effective substitution might be. In particular, notice the change in sign in the numerator denominator here. Here we have a minus, but here we have a plus. It seems plausible that either replacing the numerator or the denominator with w might help. So it's worth thinking about the two options. Take a stab at it for a moment now, and then we'll check in a moment. Okay. I think it's worthwhile not answering this right now, but actually exploring what happens if you try each one. Again, one of the major lessons in integration is perseverance can be just as important as cleverness. If you're willing to try things and see where that leads, it's easier to see where things go wrong. Don't try to integrate all these in your mind right away if you're having any difficulties at all. Go through the process, see what went wrong, fix the process, start again, and try another approach. Let's start, as a first attempt, taking the w from the numerator. If we do that, and we take the derivative, we're going to get e to the x again, minus e to the negative x, but the derivative of that is going to be -1 from the chain rule, or dw dx is going to equal e to the x plus e to the negative x. That's not too helpful yet. We want to isolate dx. We can do that just by moving pieces around, the dx up, this down. 1 over e to the x plus e to the minus x dw equals what we get on the right-hand side as a dx. So let's call this integral I so we don't have to recopy it. This integral can be rewritten. We gave the numerator a name. That's what we called w. That was our substitution at the top. And then the bottom, the bottom isn't equal to anything because this is dw, so we'll have to leave that as is for now, as e to the x plus e to the negative x all squared. And then the dx we replace with this expression here, 1 over e to the x plus e to the minus x dw. And here we end up with w over, we have the same expression at the bottom, squared first times another one, that'll give us e to the x plus e to the negative x all cubed dw. This is a hot mess right now. In particular, it is a hot mix of w's and x's. As soon as we have that mix, there is nothing we can do, especially there's no way to get rid of it by manipulating our w's or x's, and I don't see a way to make that work here. This integral is also not simpler in form, which is kind of irrelevant. If we have a mix of x and w's, we can't evaluate it anyway, no matter what we try, but it certainly does not look simpler than what we started with. But look how relatively short this effort was to recognize that something went wrong. Do not hesitate to go down these kinds of paths, piece of scrap paper, little side calculations, and just be able to recognize when things haven't gotten better. Go back to the start and say, oh, let's try something else. What if we had tried picking the denominator side here, the inside of this, as our w? Again, once we've made that choice, we just turn the crank of the process. We compute the derivative, dw dx, that'll be e to the x. And we're going to have minus e to the minus x, because the derivative of the exponent here is going to put out a -1. That is a factor in our original integrand, so that is likely to be helpful. Same thing as always though, we isolate our dx, so we get 1 over e to the x minus e to the minus x dw. The dw stays where it is, and then the dx moves to the right-hand side. Once we've done that, we can rewrite the original integral. It'll be the integral of e to the, we did not substitute that for anything, so the numerator is going to stay the same. the denominator is going to change. We said w is equal to that stuff there, and it was all that squared. So we'll have a w squared in the denominator. And then, wait, the original integral had a dx. So we'll replace it with this, and that looks gorgeous because we will be able to cancel things. This 1 over e to the x minus e to the minus x is what it ends up here. We can cancel those two things, and we end up with the integral of 1 over w squared dw. This is lovely because there are no x's, and it is far simpler than what we had before. We've traded this complicated looking integral at the top here for this much, much simpler integral now. To evaluate it, it's always safer to write things as powers. So we just look at it as in a different lens. The reason being then we can add 1 to the power and divide by the new power and put a plus c. That is where we actually do the integration step. Once we've done that, we just go back to x's. What did we have for x's? Well, we had w, here it is. W equals e to the x plus e to the negative x. So negative. Negative exponent means it's in the denominator. 1 over e to the x plus e to the negative x plus a c. And that would be the integral of this complicated looking beast at the top, arrived at through a sequence of substitution steps, choosing one substitution and then finding the new integral from that was easier to evaluate. And contrasting it with, again, I don't want to say the wrong choice for the w, but just a choice that isn't helpful. Don't think of it as a serious commitment if you try something and it doesn't work out, because it's easy to go through those steps and then try something else if you got, as you did here, an integral that didn't get rid of all the mix of x and w's. You didn't get a pure integral with a single variable, which is what you needed. But you just go back, try this other alternative, and things worked out much better. So going back a slide, which ended up being more helpful, this one, and there were some clues that might be a good choice at the outset if you were looking for them. Remember that we want something on the inside of the function. In some sense, this numerator is not on the inside of anything, it's just a multiplier. This is really something buried in a denominator and buried in a squared. This would be my first choice just based on the way the chain rule works. And as it turns out, this is the choice that leads to a simpler integral more efficiently.